Hi, we are the ASME student design team from NC State with the sail. So for the measurements, we're going to go from the outside edge all the way across. It's a square, so it doesn't matter, and it's exactly 5 meters. If we cross the edge, that's when we're disqualified. So if we go off the mat, because tape won't hold up across the edge of the mat. Same thing for here. I mean, it makes sense, it's a square. These, I'll go one at a time, are a meter or less. I'll just lock it. There we go. Wait, I had that to the wrong place, sorry. There we go, that's the right place. And then the arrows are as presented in the documentation. For our weight demonstration, we will first calibrate the scale with a 50 gram calibration weight. I, Bennett Meyer, certify that we have calibrated our scale for the measuring of these weights. Weight number 1, 490.8. Weight number 2, 490.6. Weight number 3, 490 exactly. Weight number 4, 490.4. Weight number 5, 490 exactly. Weight number 6, 490 exactly. Weight number 7, 493.6. Weight number 8, 490 exactly. Weight number 9, 490.7. Each one of these steel plates had to be augmented with a lead addition of some sort, pushing them beyond their standard square form factor due to the fact that we could not reorder the weights, but they were under the density that we expected. I will now go through and show the measurements roughly. I'm not going to even call that out. It's just going to be what is shown.
I don't think
to the Q&A.
I don't think you have to do all of them. They probably trust that they're all the same size.
Yep. That's good enough. Honestly, yeah, just do it that way. For our renewable energy sources, we use the recommended/required fan and halogen light, being the Lasco wind machine air circulator and the Utility Tech halogen 500 watt work light. For our energy source, we used the recommended/required Amazon Basics AAA rechargeable batteries. As you can see, it is the one that is in the system. It is the one that we will show is in the system during the competition. I, as the team lead, certify that it has not been altered and that it is the only power source in the system. For our storage box, demonstration, you will see that inside is our entire device, including our controller. Removing it from the box and measuring from the base to the height, you can see that it is 25 centimeters tall. It is 30 centimeters in width and 41.5 centimeters in length, well below the 50 centimeter requirement in all three dimensions. Okay, so this is our battery power source. Technically, this is our control system, and this is our charging circuit. It will operate by converting the 1.2 volts into 5 volts to power a dual relay remote switch, which is controlled via this remote. So we can drive either the left or right motor forward and give us steering or movement forward. The 24 volt solar panel is dropped down to 5 volts and regulated for the charging circuit with this regulator. We will be demonstrating the solar power collection system. For this demonstration, we will show that the current will be positive whenever the light is on, indicating charging of the battery. The multimeter is reading 0.14 amps at 5 volts.
I, Bennett Meyer, as the team captain of Team Sail, state that we intend to use solar power as our energy source.
I, Bennett Meyer, the design team lead for ASME student chapter at NC State, hereby pledge that our team, the Sail, will comply with all SDC rules and clarifications.